In this video, I'll show how to sort in a rotated array. The problem statement: the input is a rotated array, which is array, a number, which is target. The rotated array means part of the sorted array has been moved to the front. For example, the sorted array is 0, 1, 2, 4, 5, 6. The rotated would be 4, 5, 6, 0, 1, 2, because 4, 5, 6 has been moved to the front. The output is what index is the target on the rotated array. For one example, when the array is 4, 5, 6, 0, 1, 2, the target is 1, the output would be 5 because that is the index of 1 and 1 is the target. For example 2, when the target is 8, and the array is this, the output would be 2 because that is the index of 8 and 8 is the target. And the reason why we don't use a simple for loop to look for a target is because you might be thinking that all you have to do is just for loop. However, that would take O n time. With this algorithm, it will take O log n time. Observation. For one observation, linear search takes O log n time, but needs a sorted array. As array is rotated, the first part of the array is sorted first and the second part of the array is sorted 0, 1, 2. We need to find at the smallest element 0 index, start. If the target is between start and right, search on the right side. If the target is between left and start, it will search on the left side. Algorithm. Search and rotate array. Algorithm. Function search and rotate array will take the input array and target. If array is none, that means there is no array. Or if length array is 0, that means array has nothing in it, it will return -1. It will initialize left to be 0, left is the left pointer. It will initialize right to be at the end of the array, and right is the right pointer. Now then the while loop, while left is smaller than right, to make it, and it will leave the while loop once it finds the index of the smallest element. It will bind and search as long as left is smaller than right. Insert array left side value is smaller than right side value. If array midpoint is bigger than array route, we know it's not sorted, so we need to search on the right side. But you could do that by doing left equals to midpoint plus 1. Since 8 is bigger than 2, it will search on the right side. Also initialize midpoint to be 4, so initialize midpoint, which is pointer between left and right, which will do right minus left first. So 5 minus 0. Divide by 2. In this case, 5 divided by 2 is 2.5. And so it will return the integer value of 2.5, which is 2. So midpoint is 2 plus f, which is 0. So midpoint is 2. So that's why array midpoint is bigger than array right, because array midpoint is 8 and array right is 2. And then initialize midpoint again, this time to be the middle of this new left and this in the same right, by doing the same thing, right minus left, which is 2, divided by 2, which is 1, 2 plus 3 is, divided by 2 is 1, and 1 plus 3 is 4, so midpoint is 4. And array midpoint, which is 1, is smaller than array right, which is 2. And so that portion of the array is sorted left between left and right, including left and right. That part of the array is sorted. It will search the minimum on the left side, but right equals the midpoint, so now search on the left side. Initialize midpoint again to be between left and right. Right minus left, which is 1. 1 divided by 2 is 0.5, and 0.5 integer value is 0, and 0 plus 3, which 3 is left, and 0 plus 3 is 3, so midpoint is 3. And then because array midpoint is not bigger than array right, which is because 0 is smaller than 1, it will search me around the left by making right equal to midpoint. Now that right is midpoint, left is not smaller than right anymore, and 1 left is equal to right, that means it's found a minimum value, which is 0 in this case, so it stops the search. And initialize start to be left to point to the minimum value in the array. Left will go back to 0, and right will go back to be the end of the array. If target is smaller than left and start, it will search on the left side, because that's what target is. If target is bigger than start and right, it will search on the right side, because that's what target is. In this case, since 1 is on the right of start because it's bigger than start, it will look on the right side of start. So to do that, it will do left equal to start. Binary search until left and right meets. If target is smaller than the midpoint, search until also it will create midpoint by doing the same thing. 5 minus 3, which is 2. 2 divided by 2 is 1. 1 plus 3 is 4, so midpoint is 4. If target is smaller than the right midpoint, it will start on the left side. If target is bigger than the right midpoint, it will start on the right side. If target is equal to midpoint, then it will return the midpoint index, because that's the index of target, because if the right midpoint is equal to target, that means you found it. That means the midpoint is equal to target, and so the index of a midpoint is 4, because midpoint, we now have what the index is, and that's midpoint, so we'll return midpoint. So then the output is 4 because we returned midpoint, which is 4. The end.